Okay, so on behalf of the New Space Researchers Workshop, I'd like to welcome you to the second webinar in our three-part series. These webinars are being held leading up to the New Space Research Workshop, which will be held on 4 May 2015 in League City, Texas. The early bird registration deadline has already passed, but we're really excited to invite everyone to come join us for the conference, as well as the Space Earth Sea Summit that's going to be held that same weekend. So from 1 to 3 May in the same location. We look forward to having some great speakers at these events. So we'd like to invite you now, a little bit ahead of time, to also join us for Webinar 3, which is going to focus on educational opportunities, and it will be held on 2 April 2015 at 2000 Eastern Daylight Time. Please look for all of our webinar links at our conference webpage, which is www.nsrw2015.org, and plan to join us for these events. I'm Tanya Estes. I'm currently serving at the United States Military Academy. It's my pleasure to introduce two of our three guest speakers in this particular webinar, Steve Ord and Alex Van Dijk of the NASA Flight Opportunities Program. So I'd like to just give a brief introduction. Stephen Ord is currently the Technology Manager for the Flight Opportunities Project. Stephen has held several positions in engineering and management during his 28-year career at NASA. Alexander Van Dijk has been with the Flight Opportunities Program since its inception in 2010. Today, he supports the Flight Opportunities Program in a variety of roles, including technology maturation, tracking, and program communications. He works out of the NASA Ames Research Center in Moffett Field, California. So again, welcome, gentlemen. Thank you for joining us today. Steve, can you tell us a little bit more about the Flight Opportunities Program? Give us an overview.
Sure, Tanya. Thanks a lot. Yeah, first of all, I'd like to say that about a week and a half ago, we had a balloon flight. We launched 2 payloads then. And they've been recovered, and the folks are looking at the data now. We'll see how good the experiments went, but we're definitely an active program here. Flight Opportunities is one of 9 programs within the NASA Space Technology Mission Directorate, and those 9 programs basically deal with different technology levels. If I show you the chart here for technologies, this chart here shows that we're actually Flight Opportunities. We're the purple here, and as you can see, we're at TRL level 4 to 6, and that basically around TRL level 5 to 6, what you're doing is you're flying your technology in a relevant environment. The technology readiness level is kind of a measure of how far your technology is along. These early technologies in TRL level 1, those are in benchtop mode. They're demonstrating basic concepts. They're not really ready for flight. And TRL 7, and actually it goes higher than that, TRL 9 is basically you're in the environment and you're operating with an operational system, and it's been fully checked out. So we cover this range here, the purple range. We basically take experiments that are pretty much ready to fly in the environment. They're not quite in their final package yet, but they're ready to fly and get the space environment, and then they usually exit our program at TRL 6. Other programs within these 9 here from the Space Technology Mission Directorate, you can see, take the technology levels to from different levels, lower and also higher than ours. So I just kind of want to note that we're one of several programs within STMD that basically helps people advance their technology. So let me go back from that. Excuse me a second here. There we go. So that's kind of an overview of where we sit within the Space Technology Mission Directorate. The vision of the Flight Opportunities Program is to focus on technology maturation. We're trying to help technology thrive and grow. And there's particular areas in which the Space Technology Mission Directorate is interested in growing, and I'll bring that chart up here and show you that. Hold on. Oops, there we go. So this chart here shows the different thrust areas for the Space Technology Mission Directorate. So we look at all kinds of different things. We're looking at typically on a flight opportunities flight, you might have entry and descent and landing systems that are controlling a vehicle near the ground. You might have people looking at the technologies themselves, fluids behavior within space, managing propellant tanks, things like that. So we cover the whole gamut of technology within the program, whatever people are trying to advance, as long as it meets one of the STMD needs, we definitely are interested in flying it. So let me move on a little bit from there. Just a second. Oops.
Now, it was interesting that you mentioned the fluid behavior. I saw some interesting experiments with fire in space, which I thought was fascinating because it behaves very unusually as well.
Yeah, and we've had a couple of actually fire extinguisher experiments, and looking at what happens and how to put out fires, and there's definitely a lot of things that happen in space that are unpredictable, especially even things like boiling water get really funny in space. You don't have buoyancy effects and things like that as the fluids are moving and stuff. So there are also things in the biological realm, obviously, that happen a lot differently. So we're definitely seeing technologies evolve in a lot of different areas. So we do have different platforms that we use for flying. Basically, our job in the Flight Opportunities is to provide platforms for folks to fly their missions. And so if I show you that here. Whoops, not that one. This is not quite as smooth as I wanted. Okay, here we go.
You're fine.
Here's a kind of a slide of relevant environments. We do parabolic flights, and so the aircraft actually goes up and down in kind of a sinusoidal manner, and so you'll have periods of microgravity, maybe 18 seconds. And then you pull out of that parabola, and you'll pull about 1.8 Gs when you recover from it, and so you're kind of going along in kind of a porpoise fashion. We also have Zombie from Maston Space Systems on contract, and that's basically more of a close to the ground, under 1 kilometer altitude, but they will test entry, descent, and landing systems and algorithms and instrumentation. And those are kind of exciting. Virgin Galactic, as you know, unfortunately has had an accident, but they are part of our program, and hopefully someday we hope to get some flights done with them. Spaceloft is one that is a workhorse for us. They provide a sounding rocket that goes up and provides about 3 to 4 minutes of weightlessness, and some pretty good altitude, 120 kilometers. So, and Lynx X-Core is not online yet, unfortunately. And we do hope that someday they will, and they'll also hopefully provide a few minutes of weightlessness when they finally get there. We also do balloons, as I mentioned. We just had launched one about a week and a half ago, and then there's also a high-altitude shuttle system that comes from the balloon and actually lands and returns the payload. So that's kind of an idea of the vehicles that we use within the Flight Opportunities program. Moving on. We basically our bottom line, as well as trying to fly the payloads for STMD, we're also trying to foster growth within the emerging commercial industry. So these companies that are like Spaceloft or Virgin Galactic, we're trying to help them also grow. So eventually we're one of many customers that they have within the system. So now I'll kind of turn it over to Alex to kind of talk. Alex has been on the program for a long time, and I'd like to turn it over to him. He can talk about kind of the history of the program and some more detail there. Alex?
Yeah, thanks, Steve. Good morning. Thanks for having us, Anya.
Oh, thank you, Alex.
Well, so real brief. The program has been in existence for 4 years, and like Steve mentioned, we're helping to stir this suborbital commercial industry. And from the beginning, back in late 2010, there was not really anything in existence. The companies were just starting to develop their vehicles, and NASA, as a government entity, came in as an early customer to provide them with early revenue for them to continue to develop their vehicles. So basically, the first 3 years we've been booting up our program, which means that we've been working on both the supply side, which is the platforms, and the demand side, which is the researchers that need to test their hardware in the relevant environments that these vehicles provide. And we've had several rounds of solicitations where we've selected in payload proposals, and then we've worked with both sides, the PIs and the flight providers, to get the first flights off for all the vehicles that Steve just showed. So it was mainly a boot up phase, I think. And then FY14, which is what we just finished last September. Given that we have succeeded in booting up these flight services for payloads that are of interest to NASA, we've transitioned a little bit to a more operational mode. And one side of this is that we've renewed our contract with some of the flight providers that we started out with 4 years ago. Mm-hmm. And these are called, so the contract that NASA has with these flight providers is called an IDIQ, which basically, it stands for indefinite delivery, indefinite quantity. And that basically means that we have them on contract, and then using that vehicle, we can issue task orders to these flight providers to fly specific missions. And on IDIQ 1, we had 7 flight providers, but some of them are still in development, so they can't provide the flight services yet. So what we did with IDIQ 2 is we've only selected those flight providers that are actually in an operational mode. And the 4 companies that we currently have on that IDIQ 2 contract are Mast and Space Systems, the one that does the entry, descent, and landing testing. Up Aerospace, which is the sounding rocket. Virgin Galactic, and we've selected a new flight provider for the balloons, for the balloon testing, and that is a company called Worldview out of Tucson, Arizona. Now, given that we moved away from having 7 flight providers on contract, where some of them were still in their development phase, to the current model where we have 4 operational flight providers, we still want to support the development of these other companies. So what we've done is we've released an RFI late last year, which is currently in review, where we are looking to build public-private partnerships between some of those companies and NASA to transition some of the, NASA has a lot of knowledge in this domain, obviously. So what we're looking at is setting up public-private partnerships where some of the NASA centers that have technology and know-how that could be of interest to those companies could be shared, and NASA can work together with those companies to continue to develop and get them to an operational mode. And once they are at a stage where they can provide actual flight services to our program, we will grandfather them into this IDIQ2 that we set up. And on that RFI that I just mentioned, we also included a new flight environment, which is small-sat orbital. And I'm sure the community knows there's a lot of chatter these days about this emerging market of small sats and small sat constellations. And we are looking to support the companies, and some of the companies that are looking at developing launch capability to orbit are some of the companies that we've worked with in the suborbital realm. So we sort of look at broadening our vehicle base a little bit. The other thing that we've done, because the other vehicle that is a workhorse for us is the Parabolic Flights, and our contract with Zero Gravity Corporation, that was our flight provider up to mid last year, ended. So we also have an RFI out now that we're looking for setting up a new contract with a commercial flight provider for Parabolic Flight services. So I think overall the first 3 years mainly booting up. This last year was sort of a transition to more of an operational mode, and I think we're pretty well set now to start or to continue to provide these flight services for technologies that are of interest to NASA, and also to continue to support the development of that industry. So that's a small recap of how we got where we are currently. Steve, did you have some other?
Sure. Yeah, I'd like to talk a little bit about how to propose to flight opportunities. Some of you, this may be old hat, because as Alex said, we've been doing this for a while, but for those of you who haven't been involved, in the past we did do announcements of flight opportunities, and basically it was a great vehicle to get payloads flown, and basically NASA would do a lot of the manifesting and flight provider interaction for you, and basically you had to show up with a payload, and that was kind of it. But in FY15, we're trying to do something a little different with this latest Ready call. It's the first call we did under this type of announcement program, where instead of the managing of flights coming from NASA, the payload folks are actually asked to go out and find their own flights and figure out what they want to fly on, and then propose that to NASA with the technology, and then NASA will do a selection. And we're right in the middle of a Ready call right now that went out, closed on November 20th, and so now the evaluation process has started, and then hopefully we'll be selecting some payloads here to fly. And those payloads would be from people who have actually selected their own flight providers and are working directly with them. So we've changed the system a little bit, and hopefully it's going to work out well. We plan to issue calls hopefully more often than annually, so that we can keep that payload pipeline flowing and keep the technology development going. I would like to point out that the Ready call is kind of like our previous calls. It's not necessarily science-oriented. These are not science flights that we normally fly. Normally we're flying technology development flights. So if you have a technology that you're looking at, maybe a new sensor or something like that, that eventually will be used for science, but it's not there yet, technology isn't quite finalized yet, then certainly that would be something that we would fly. So I just kind of want to make that distinction. There are Science Mission Directorate, a different directorate than the Space Technology Directorate at NASA, also issues calls. They have a ROSAS call that was just issued. Alex has a newsletter that he sends out, which kind of alerts people to those. And so they're actually calling out the Flight Opportunities Program within their call. It's actually in Section 5. And they're looking for demonstrations of science instrument technology. And so we're kind of working with them to be funded for the development of the technology, and then on our side actually flying the technology. There are also other payload development opportunities. If you're looking for development of the payload, we normally take the payloads as they're already developed and at a TRL level of 4, and then we fly them. But if you need help in getting the technology developed, there are several different avenues for that. As I mentioned earlier, the ROSAS call from SMD. There's a University Space program. There's a Human Exploration Operations Mission Directorate at NASA also issues calls and can help with early TRL. And also, as I mentioned before in the STMD chart on the TRL levels, STMD has 9 different programs, and within those, some of them also foster development of payloads at the lower TRLs to get people started. And so there's several ways to get funded outside of the Flight Opportunities Program to actually develop your payloads. So I just kind of want to mention that. So Tanya, I think that kind of gives you a background for what the Flight Opportunities Program is all about. So I'll go back to you.
Great, gentlemen. This has been extremely helpful. I guess the only question I would have is do you have any more advice in terms of, you've given us a lot of advice on how to propose a payload, but anything in terms of, you've kind of specified the types of payloads perhaps as well, the technology versus new science. Any other advice you've got for putting together payloads, or anything that you've seen people run into difficulty with or struggle with that you might be able to share with everyone out there?
Definitely. And so we have our campaign managers who actually go out and work with the payload providers to get them on the flights, and they have a lot of experience. And so a lot of times we hear things such as, make sure you get your requirements nailed down up front. Don't show up on the flight day and say, hey, by the way, I need 24-volt DC power at a couple of amps. Can you guys throw that in for me? That's difficult to do. And so things like that, things like documenting your success criteria, be very clear on what satisfies, what's a satisfactory test, and make sure you look at the user guide from the payload providers. They all have user guides that tell you how the system works and everything, and you can contact them, get plenty of information. So that's definitely recommended. When you show up for the flight, a lot of times there's weather delays and stuff like that, so you have to be flexible for these types of flights. And with any flight, I think a lot of times we get delayed, especially with with weather around certain parts of the year. So you end up having to be flexible there. Just trying to think of some of the other things. Alex has actually flown on parabolic flights. Alex, do you want to talk about maybe some of the things that that you learned from doing parabolics, and what kind of things might help payload developers there?
Sure. Well, so we talked to Bobby Rowe, who's the campaign manager on our program for the parabolics, and they're flown out of Houston, by the way, out of Ellington Field. And he said, and it's a good point. So we have a bunch of photos of our campaigns on our Flickr account, but you don't see the transitions going from 1.8G to 0G on a photo. So he recommended, and it's a very good point, to go on YouTube. There's tons of videos about parabolic flight, from both us and other programs that came before us. So if you want to get a feel of what the environment is actually like in the plane, just do a Google search or a YouTube search for parabolic flight, NASA or something, and you'll see some videos where you can see very clearly how the PIs interact with their payloads. Also, what those racks look like. I mean, the aircraft has an advantage that it's a very large space. So some of these payloads are actually pretty big and also rather heavy. But yeah, that's a good way to sort of familiarize yourself. Also, the RGO office, which is the Reduced Gravity office out of Johnson Space Center, that is our provider for the parabolic flights, has decades of experience, and they have several documents on their website. If you do JSC Zero Gravity, you will find their website, and they have tons of documents that sort of give you an intro into the plane, into what types of rigs you are supposed to develop, what requirements there are. There's tons of information there. So on the parabolic side, I think checking their website out is a good idea. One note is that. And that's something we've been getting back from the PIs that have flown and submit their reports back to us, is that the microgravity environment, some people think it's minutes, some people think it's half a minute or something, but honestly the real, during the parabola, as you go over that hump and get the microgravity, the free fall, it's usually only in the order of 15 seconds. So you want to make sure you are aware of that and that you design your experiment and that it will do what it needs to do in those short, brief periods of time. And also there is some lateral drift sometimes. It kind of depends on the weather again. We fly over the Gulf of Mexico, so some campaigns, depending on which time of the year, might have some issues with that. But I think, and also I'll show you later, but the Flickr site where we've flown 16 campaigns to date. So we also have a lot of experience and a lot of photos from those campaigns where you can see how people work on their rigs before the flight week, at the hangar at Ellington Field. And I think familiarizing yourself with those photos and just with the general context within which you're going to fly is very helpful. I think in terms of like hardware requirements, one thing that Bobby mentioned was you can't use any plexiglass or anything that is shatterable. Obviously, is a risk on board. So there's it's an interesting environment, and you got to make sure you comply with all the regulations and all the requirements. Otherwise, the review board, which is there on site on the Monday before the flight week, will just basically turn down your payload, and you're not allowed to fly. So it's very important that you come well prepared. But that goes for everything, obviously. So.
Yeah.
Oh, go ahead. I'm sorry, Steve.
I was going to say I'd like to add. In talking with Paul De Leon, he's our campaign manager for the balloons. Something else that you don't normally see is he was talking about when the balloons come down. Sometimes when they land, they actually drag. Some of these parachutes are almost like parafoils, and so they might drag, and so your payload might actually tumble and things like that. So it's kind of those things you need to consider when you're designing your payload and thinking about it. It's probably not going to come down in a very soft, perfect situation with no impact. You actually will. It's not going to be a crash landing, but you do have to consider the fact that the payload might rotate or roll around a little bit. If you have a sensitive instrument sticking out, for instance, you'll have to protect it. But there's ways that that's done. It's not like they can't take care of those kind of problems. There's definitely ways to do it. And the final thing I'd mention that Paul has mentioned too is that you have to test for the launch environments. Before you go. You want to do electromagnetic interference testing, particularly for the balloon flights. Sometimes the payload's electronically interfere with each other, and so you just need to make sure that that's not going to be a problem. And if it turns out to be a problem after testing, then you do shielding or whatever you need to take care of it. So that's kind of a general spiel, I think, from how to get your payload, practically speaking, into the Flight Opportunities Program and make it successful. I think Alex, do you have some notes to add on kind of further information for the how to get in touch with Flight Opportunities, etc.?
Yeah, sure. Yeah, let me see if I can share my screen. Here we go. Okay, so just a few pointers. There is obviously a website that we have. Let me jump there myself. So this is our website. It's at flightopportunities.nasa.gov. And if you scroll down to the bottom, we have, first of all, we have, and again, this is, if you want to familiarize yourself with sort of the types of payloads that we fly. Are you seeing this? Let me check. Yeah.
Yes.
Okay. So,
yep.
We have a section on our website where we detail all the payloads that we fly, and there's, I think, 142 at present. And I'm just going to randomly jump to one. Let me see. So each of these, like this is an interesting one. So each of these has a small detail of what their objectives are, what their maturation objectives are, what their downstream customers are, or where they want to go beyond our program. And then we have a Panda chart, that little green button. That if you click that, it has a quick overview of the problem statement and sort of the point of context, and feel free to reach out if you have further questions for any of these to the PIs themselves. And this is actually an interesting one because we flew this on a parabolic flight, I think a year or two ago, or maybe a year ago, and it just recently got launched from ISS. I'm sure you've all seen those CubeSat deployments from ISS. This was one of them. This 3U CubeSat got deployed into low Earth orbit after they tested their 2U. Well, they have a 1U payload and then a 2U bus, and it's a Earth observation system. But this is an example of how we test subsystems, and then once they've validated their hardware, their subsystems, they go on to deploying it in actual operational environments. So another thing to point out is some social media that we use, and the main one is Flickr. So we have a Flickr account where we post photos from all our campaigns, and this basically goes in back chronological order. So at the bottom right, it starts with our first campaign we flew almost 4 years ago. So these RGOs are the parabolic campaigns, and then if you read to the left and up, you can see sort of a history of all the all the campaigns that we've done. There's a lot of parabolic flights. There's some zombie flights, the EDL, the entry, descent, and landing. Some up aerospace. I don't know. Let me jump. Well, so here's the last one we did, the Worldview balloon flight that Steve mentioned. So you can see the rig. This is all pre-flight, pre-launch. Tons of photos. You can sort of get a feel. This is the actual rig within which the two payloads were mounted.
Nice.
Let's see if I can blow this up. So, and I sort of post all the photos that we can get because I think even though they're a little bit shaky, it always gives you some information. So don't expect only sort of the highest end photos, but it gives you a good feel. And then here's the actual, through the night working to inflate the balloon, early 6 a.m. Launch, I think. And then it came back. And so this is what Steve was hinting at earlier. This payload rack, landed and a little bit. Came down and dragged a little bit, so it was somewhat deformed. But this 80-20 system that you can see, this sort of structure there, is the standard structure that is used both on parabolic flights and also on balloon flights. It's a very versatile system, very flexible to build rigs that are low cost. So that's I think a very good resource for people to browse through. It's kind of fun to look at some of those flights. And then we obviously have a Twitter account, which is a good place to keep up to date as to some of the flights that we've successfully done. Let me quickly show you one example. This came out just I think yesterday. Mm-hmm. We had some flights with Maston. JPL was flying on the mast and zombie vehicle. And here's a little video. Well, I'm not going to show it now, but anyway, you can on our Twitter account is a good place to keep up with the latest news. Also, we'll publicize any calls that we have or any opportunities that we are publicizing or promoting. And then lastly, there is a mailman list, an email list, where you can subscribe to, and we use that also to publicize all the potential flight opportunity calls that we do, or other programs within STMD that might be of interest to the community. So that's a good place to start, I think, to sign up, and it's a rather low traffic mailing list, so we won't bombard you. Now, if you're interested in sort of the history of the program, I would recommend browsing through this annual report that we did, which is also on our website. You can open it up. And it gives you sort of a description of the history of the program, sort of what I ran through earlier, with all the vehicle testing. For example, this is out in Mojave, where Mass and Space Systems is testing their vehicle. So I think there's a lot of information out there. Obviously, if you have specific questions, you can also go to our Contact Us page, and that will open up an email that gets sent directly to me. So if you have any further questions, please feel free to send me an email through the Contact Us on our website. Yeah, I think that's about it. Yeah. So back to you, Danya.
Well, I'd like to thank you both, gentlemen, for joining us, and this has been extremely informative. I know I've learned quite a bit, and I'm sure all of our viewers will as well. So again, thank you both for joining us, and we look forward to being able to work with you in the future, hopefully.
Thanks for the opportunity, Tanya. We appreciate it.
Thank you.
Thanks, gentlemen. Have a good afternoon.
Bye-bye.
All right. You too.
Okay. And so during this period, we're going to go ahead and wait. We're going to have Ted Southern will be joining us from his organization, and he is the president of Final Frontier Design. So as he joins us, we're going to have him talk to us a little bit about some of the challenges and things that he's encountered in designing spacesuits. So specifically those more used for on-planet. And here, it looks like we've got Ted joining us here momentarily. So once Ted is on, Ted, good afternoon.
Hey. Hey, Tanya, how are you?
Good. How are you doing today?
I'm doing okay.
Good. So we're already live. I went ahead and we're segueing from Alex and Steve's discussion, and I'll do a more in-depth introduction. I did a very brief one. So I'd like to introduce Ted Southern. He's the president of Final Frontier Design, a startup suit design company operating near the Brooklyn Navy Yard, or from the Brooklyn Navy Yard. Ted has a Master of Fine Arts in Sculpture from the Pratt Institute and has served as principal investigator on 3 NASA Small Business Innovation Research contracts since 2011. So Ted, first of all, welcome. And can you please tell us more about Final Frontier Design and some of your experiences in creating flight-ready technologies?
Sure, Tanya. Thanks so much for having me. And I think the best way to kind of illustrate what it is that we do here at Final Frontier Design might be to share a PowerPoint. So I'm going to attempt to do a screen share here.
Absolutely.
And so I have a basic PowerPoint of just sort of an outline of our suit. Oh dear, I'm getting a phone call.
Okay.
So Final Frontier Design is a small business operating out of the Brooklyn Navy Yard. We've been in business about 5 years, working specifically on spacesuits, not just IVA but also EVA parts. But our big drive lately has been our IVA, intravehicular activity spacesuit. And we recently signed a Space Act agreement made public in December to essentially flight qualify or human rate our spacesuit for orbital spaceflight. It's a long road, a long process, and we are just trying to navigate the intricacies of it now. Our suit is designed to operate up to 5 psi, and obviously it's designed to be highly reliable, but also low cost, low weight, minimal profile, very sizable. What we're really trying to attempt is to make a commercial spacesuit. A lot of the IVA spacesuits that NASA use now are essentially military heritage garments that we feel like aren't really appropriate for the next generation of commercial space travel. There is a chest-based entry and an integral helmet. And the suit is highly adjustable. That's myself on the right in the suit. I'm 6'4". My pattern maker, lead pattern maker in Final Frontier Design is 5'2", and she also fits in our suit.
Excellent height. On the small side.
We got to try that, Tanya.
Excellent.
The suit is under 15 pounds with just the pressure garment, and the outer garment adds about 3 more pounds. We've done human tests both with parachutes and also illustrated here with oxygen masks inside the suit. In addition to doing cockpit evaluations and also flight testing. So we've flown the suit pressurized both in a glider and in an aircraft with some pilot capabilities. We've also done a fair amount of cycling tests and burst tests over the years. This third generation suit represents actually 5 suits that we built here at Final Frontier Design in almost 5 years of development. Our company, as I mentioned, is a very small business. It was founded as a partnership between myself and Nikolai Moiseev. My partner Nick has a degree of aerospace engineering from the Moscow Aviation Institute from 1986, and he worked over 20 years at Zvezda on both IVA and EVA components.
Wow.
So that's sort of a basic overview of what it is that we're working on at Final Frontier Design. And I guess with the discussion today, we're talking specifically about qualifying flight-ready hardware or preparing to qualify flight-ready hardware. And that really has been the struggle of our business. We had a Kickstarter campaign almost 3 years ago now, and our goal at that point, gosh, I'm getting all these texts. I get it on my phone or something, of course.
You're okay.
Our goal in 2012 was flight certification with quotes around that, and we had a naive goal that if we could raise $20,000, we could achieve flight certification. Here we are 3 years later, and we're still aiming towards that goal, but have found it just to be much, much more complex than I think we could have anticipated. At Final Frontier Design, and I'm sure as a lot of people at this conference are coming kind of from an outside perspective, they're probably not within NASA, and trying to understand the NASA system, NASA human rating, especially when it's a commercial project and not necessarily a NASA mission, an internal NASA mission. Getting those certifications and just sort of even understanding the process can be a very difficult challenge. We're really excited to have been chosen for this this competitive Space Act agreement. We really feel like, early on I got some advice from some folks over at Honeybee Robotics, which is just down the road from us here in New York City, and their advice was essentially find somebody within NASA who can hold your hand and help guide you through the system, because it's not something from the outside that is easy to navigate, and I feel like with this Space Act agreement in place, we've really found the right excuse, the right people, the right advocates to sort of help us navigate the system and understand the basics. There are a plethora of standards and directives within NASA that talk about everything from how to climb a ladder and cross the street safely to how to handle liquid hydrogen and sort of everything in between. And just navigating that and understanding what's applicable to you and what isn't can be a tremendous challenge.
Absolutely, and actually one of the things that I find fascinating about your work is that you started with the glove challenge, and I know that the gloves have been a particular difficulty just because back when they were first being designed for the EVA suits 30 years ago, the gloves would be so thick it's almost impossible to get real maneuverability with your hands, and that's one of the reasons why Robonaut came around to try to provide some very fine, dexterous control in hostile environments. What did you find in your glove design? Is there anything in particular that you found that kind of helped with the mobility of the hands, or is that still a challenge, do you think?
Well, specifically, in fact, our glove designs from the glove competition kind of defined or guided our full suit design. Our strategy from the get-go was to create a single-layer pressure garment. So currently, NASA suits have an internal gas bladder and then a separate sewn restraint. And our goal was to bond the bladder to the restraint and to use some sort of innovative patterning and design to minimize the wall thickness, to minimize friction between layers, to minimize mass, to minimize the manufacturing complexity of the pressure garment. And that we achieved that in a very rudimentary fashion, I think, for the 2009 astronaut glove competition. And frankly, we were pretty lucky, I think, over those couple days. But we've come a long way in materials since then. That original competition, we were using hand-mixed RTV silicone that was sort of patched onto the inside of the glove, whereas now we've found some commercially available laminated fabrics that are pressure tight and heat sealable. So that, even from the beginning, that initial concept of a single layer pressure garment for the gloves was really our guiding force. Our first suit was almost entirely double layered, but with the second suit and the 3G suit, the pressure garment is all single layer except for the chest entry. And that, I think, is what allows us to have such a lightweight suit. I mean, 15 pounds is kind of unheard of for a pressure garment, and it's what allows us to have such a good range of motion in the suit. I think it makes it much easier to adjust because there's not as much material, and it also, as I mentioned, makes it easier for us to manufacture. It's just one garment rather than two. So once you start digging into the technical side of the design, that really, I think, is our main feature, is that single layer pressure garment.
And one thing that I find particularly interesting about your background is that you have a Master of Fine Arts in Sculpture. How has that informed how you do your work? Because generally speaking, you've got an engineer and you've got an artist together. How has that dynamic worked, and is there anything any advice you've got in terms of perhaps maybe engineering teams want to incorporate someone with an artistic background to help inform their designs as well? Do you have anything in terms of advice in that regard?
Sure. Well, to qualify my degree, sculpture can sound like bronze castings and clay molds and things like that, and I certainly have done a fair amount of that, but my background was really in technical costuming, and almost everything I made in graduate school had to do with the hand, with building on the hand, understanding hand anatomy, and that was really why I chose the astronaut glove competition in the first place. That's how I got involved, was just an interest in, and in fact my sort of artistic motto was extending the ability of the human body. And so within that realm, that framework, I think it makes a lot more sense than just to say, fine art, sculpture. It tends to be rather broad. But I do think that even an engineer may agree that if you just let an engineer design a garment, you're going to end up with kind of a weird garment. There's a lot of sort of tailoring history back, hundreds and hundreds of years in terms of how an armhole works and how a hip joint works that can really inform the design process beyond just the concept of this is a pressure vessel that's shaped like a person. And I think we've seen that several times with some NASA testing and NASA documents where they do some rather strange sort of engineering-based concepts. Like I've seen the shoulder joint marked as neutral in this position, straight out. That's 0, according to some engineers. It just sort of skews, it sort of skews the understanding of the body that I think needs to be considered from a very sort of human standpoint. That said, there's a lot of engineering requirements too, and I couldn't do it without engineering help, and frankly, without learning a lot of engineering myself. And on a more sort of personal basis, I think it's interesting that Nick and I, over the last 5 years, have really shared a lot of responsibilities. And there's been days that, I've come in and set up a protocol, set up checklists, tried to understand, NASA's logic and the engineering logic behind things, and he'll, be in the background carving wood or something like that. We kind of share a lot of similar instincts and a lot of similar impulses. He is an aerospace engineer, but he's also a tinkerer and a designer and a tailor. And I think that what we're working on, the spacesuit in particular, is a really interesting cross between the human and the machine, and the tailor and the engineer. The creative and the engineer, and that, for us, it's been a real benefit, I think, to have that blend.
It's a really unique mix, and I'm very excited about it because I'm an engineer by background, but I also have a very artistic side. So I think it's fascinating to see those two things come together, because oftentimes we put them at odds and they shouldn't be. And so it's just kind of neat to see that you're doing that. What other things would you like to share about the process that you've gone through, or any of the experiences or challenges, other than the obvious one of just working with bureaucracy, that you might have to share with your experiences with others trying to do the same thing?
Well, I would say that, so I read this great book a while back called Fashioning Apollo, and I think that's been a touchstone for a lot of people who've come through our office, actually. And one of their points is that a lot of what NASA does is simulation. The actual flight is only a very sort of small amount of their work, and that's been sort of the name of the game in terms of qualification of our suit, is how do we simulate relevant environment, how do we understand the operation of the suit in a relevant environment without putting people at risk. And there's a lot of ways to do that, and I think that the more time you can spend before flight, before actual integration in understanding simulations, and even if it's a very sort of low-tech means, I think that can be really helpful. For instance, here at the office, we have what we call the Launch Position Flight Simulator, which is essentially a chair on its back with a computer screen and a joystick. And just given that sort of very inexpensive low-tech mock-up, there's also a 5-point seat harness, which I think is actually pretty helpful. But just given that sort of low-tech mock-up, you can understand a lot about the suit, and you can get a lot of testing data here, like without going to the hyperbaric chamber or having to get in an aircraft or anything. You can refine quite a bit in that way. I guess another sort of perspective from our end, we've kind of split up the operational environment of our suit into 4 different categories, and we're trying to be relevant from everything to training here on Earth to beyond low Earth orbit space flight, and that's a huge range. So breaking it up into categories can be really helpful, and I sort of think of them as stepping stones. So the first stepping stone would obviously be training on the ground, and that can include anything from just a basic unpressurized trial of the suit or component tests to people getting in the suit and flying in Class D flight simulators, or EVA mock-up environments, or hydrolab testing. So training can actually involve a whole lot of different scenarios. Again, that sort of simulation concept. And we actually see that as one of the biggest markets, I think, is the training market for low-cost suits like this. The next category that we define is something we call high altitude, which is essentially anything above 50,000 feet, between maybe 50 and 120,000 feet. And the vehicles that we see going there are gliders and high-altitude balloons, and potentially jet fighters with some rocket assist, or high-altitude jet fighters. There is, I think, a real category there. There's quite a few different companies, including several that we're partnered with, that operate in that environment. One of them, a quick shout out to Zero to Infinity, who's a high-altitude balloon company out of Spain. They are somewhere in the middle of the North Atlantic right now, attempting to launch a balloon to catch the full solar eclipse from the stratosphere, which should be a very interesting shot. So next up in our categories would be the suborbital category. Companies like Virgin Galactic and Xcore want to fly up to the Kármán line or above. That's pretty extreme altitudes, above what we call high altitude, but not quite orbital flight. So you're dealing with a lot of G-forces, a lot of pressure differential, and a lot of potential for excitement, I suppose, with rocket flight, but you're not quite at the level of orbital flight. And then, as I mentioned originally, that last category, orbital flight, will probably be the last category for us to kind of check the box off of and achieve. I think it's kind of the most difficult, but also the most sort of glory-filled experience in all those categories. So that's
I think you're taking a great approach. I got to meet Colonel Joe Kittinger years ago, and of course that was the classic 1959. Here's your suit, jump out of the balloon, and hope it all works out. So, but one of the things that I really like that you're doing is that concept of usability testing. So, a lot of times you can find a lot of problems. In the computer science world, we use paper prototyping quite a bit, and you just try out these designs with users, and they'll find problems for a very low-cost prototype, and it keeps you from having to do a lot of extra work, investing a lot of extra money. So I think breaking it into those four environments is probably a really good approach, because then you can spend a lot of time of design in each of those areas.
Yeah, I totally agree, and I think that our philosophy from the beginning has been build, test, evaluate, and rebuild, and we've worked with several partners and institutions in particular, where especially some universities, I think, and engineering departments in universities have this tendency to stick with CAD models for a lot of the project, and then at the end build your optimal CAD model and call that the end of the day. And that is, I think, a fundamentally flawed approach. I think you really need to understand the materials. With such a complex thing as a spacesuit assembly, CAD modeling just cannot qualify design, and so that has been an approach of ours for a long time, is to build, test, evaluate, rebuild, a very iterative process. One other thing we're running up against, and actually I was just on the phone this morning with some folks down at the Marshall Space Flight Center, their additive manufacturing facility. You mentioned Joe Kittinger, and back in the 50s, the strategy was just like, see how it goes. We don't have standards, we'll just make them up as we go. That kind of thing is still happening now, and with 3D printing being sort of a new technology on the books. With the Space Act Agreement, we're in a preliminary stage where we're trying to define the standards and the operating envelope that we're within. There are no standards for 3D printing at this point. The closest standards document that NASA would have would be the 6016, which is Materials and Processes for Spacecraft. And they talk a lot about composite materials. They talk about annealing metals. They talk about captive fasteners and everything in between. But the 3D printing was not part of the lexicon or anybody's worldview in 2004 when that document was written, and now it's huge. I mean, there's primes down at Marshall, Aerojet Rocketdyne, I think, is one of them that are printing major components for rocket engines, and out of Inconel, which is kind of phenomenal that they can print Inconel. They can print titanium down there. And to think of the complexity of rocket engines and the amount of machining and welding and qualifying that used to be required that could now be printed, that must open up a lot of design doors for them. And certainly from the spacesuit perspective, 3D printing allows a lot more flexibility in terms of complex geometries, in terms of one-off parts, or low part count, low numbers. But that's one of those things where at this point, like, we want to qualify our suit through the materials and processes program, but there are no standards, and we're kind of having to make it up as we go along, to come up with some justifications and engineering rules and refer back to standards like the failure mode analysis and part criticality, and kind of understand it from that perspective. But I think for this new commercial space industry, there's going to be a lot of firsts and a lot of new attempts to interface with NASA that haven't really been done before, and we kind of have to just jump out of the balloon.
That's kind of fascinating because, being military, that's one of the things that we see is that doctrine and standards tend to lag behind the technology. So we tend to develop equipment and weapon systems that end up being, even the Apache that I flew, by the time I was flying, it was in the mid-1990s. It was designed in the 70s. So
Sure.
you end up seeing this kind of technology lag, and here with 3D printing, you're seeing these huge surges forward, but as you've pointed out, a lot of the regulations haven't really kept up with that surge. Now, so you're talking about doing one-offs. I'm imagining very small parts. We do a lot of 3D printing here, but what you're talking about with the rocket engine pieces, those are probably pretty large 3D printers, I imagine.
Yeah, they are. We got to tour that facility in November, and they have machines. They're almost all from Germany, surprisingly enough. But they're just put in a new machine, an electron beam melting 3D printer for titanium specifically, that was like the size of two buses, and had resolution down to like 30 microns. So it's pretty incredible capabilities down there. And just in general, it's great to see that it's not limited to Huntsville, Alabama or something. You can find commercial capability out there, ISO certified commercial companies that can print in some pretty exciting materials. So it's definitely part of the future, and hopefully we can drag NASA kicking and screaming into the future.
I have to look up the ISO standards for 3D printing. They've got them for everything. Even in my field of human-computer interaction, there's all of these standards that are already out there that they've come up with. So, now, what about? Is there anything else you'd like to add to let the audience know about?
That's a great point.
If there's anything else you'd like to kind of let folks know about work that you've done, or kind of any wrap-up thoughts that you have about your experiences.
Sure. I did want to say that's a great point. ISO standards are probably a much more current way of talking about what's happening, and very good references that sometimes I think we've definitely seen it with the Commercial Crew Program, where NASA allows a little bit of pushback, a little bit of like, I think we can qualify something in this way as long as you have some logic to it. As a wrap-up, I would say I feel like I've mentioned NASA a lot, and this is the New Space Researchers Workshop, and I know that a lot of people come to the commercial space perspective with sort of an anti-NASA mentality, where the idea is that they're so bureaucratic and they're so antiquated and outdated that there's no way we can even work with them, and they're not worth interfacing with. We can do it better ourselves, that sort of thing. And I just want to come out and say I couldn't disagree more. I think that NASA personally is probably why my company exists. We were founded out of a NASA competition, and we've had several contracts with them. And I think it's amazing that NASA is willing to take a risk and hire a PI, for instance, on a spacesuit contract that has an MFA. I think that's kind of a wonderful testament. But beyond that, you can just look at the amount of money they're spending in the commercial space industry and see they are the leader in the industry, both between SpaceX and Boeing, but also with the Flight Opportunities Program that we just talked about, and with ROSAs and all kinds of different opportunities for people to interface with NASA. I really think that they're trying very hard to keep up with this industry and to encourage it and to help it develop, because they recognize, at least some of NASA recognizes, that it's really within their own best interests. And so just as an overall wrap-up, I would say engage NASA. They're there to engage you.
I completely agree. I think we're starting to see a change in the paradigm. Being within the government framework myself, there's been a huge push to try to get technology on the forefront, to try to get more commercial off-the-shelf type things going on. So it's good to hear that it's reflecting all the way across. And again, I'd really like to thank you for joining us. And also before you, we had Alex and Steve from the NASA Flight Opportunities Program. This has been an extremely informative webinar. And just as a wrap-up, I'd like to let everyone know that this is the second webinar in a three-part series. Webinar 3 is going to focus on educational opportunities. Will be held on 2 April 2015 at 2000 Eastern Daylight Time. The panelists are going to be Stephen Heck of the ARIT STEM project and Edward Wright of the Citizens in Space. Also, don't forget to sign up for the New Space Researchers Workshop, as well as the Space, Earth, and Sea Summit, which are going to be held that first week in May. So the Space, Earth, and Sea Summit will be 1 to 3 May, and then the New Space Researchers Workshop is going to be held on 4 May, all in League City. So we look forward to seeing folks there. And again, thank you very much, Ted. We appreciate you joining us today.
You bet. Thank you, Tanya.